I'm Skylar Tibbit. I'm faculty in the Department of Architecture, and I founded and co-direct the Self-Assembly Lab here at MIT. So this is our lab space. It's at the International Design Center at MIT. We have machines and materials and tanks of water all studying research from self-assembly to programmable materials and new fabrication systems. Nearly every industry you can think of, from shoes to planes to cars to medical devices, they're trying to build smarter things, smarter products. And the only way we typically know how to do that is add robotics, add devices, add batteries and motors and electronics. And what we're trying to show is that we can do the same thing with only materials. So programmable materials or 4D printing are ways that we can produce material compositions to transform in predictable and smart ways, but without robotic devices. Beyond 4D printing, we then started this much larger category called programmable materials, where we want to take any material, textiles, wood, foam, plastic, leather. We want them to activate and transform in similar ways, but with other fabrication processes, not just printing, but weaving and knitting and lamination and injecting. So we could have any material and we could make it transform based on sunlight, moisture, temperature, etc. Active textiles, the goal is to take textile materials, create compositions, and then those textiles transform based on sunlight or transform based on body temperature, become breathable, like the chair that could open and close to control the temperature, or clothing that can adapt based on your body temperature. We eventually started to develop a new printing process, our own process that is called rapid liquid printing. And we wanted to challenge the three problems with 3D printing: speed, scale, and material properties. You print inside of gel, and by printing in the gel, you eliminate gravity. So that allows us to print really, really fast. We can print small things, large things. We can print components for furniture. We can print airplane or car components, shoes. We're working on medical devices like prosthetics. So many, many different applications that can print super soft all the way up to really rigid materials, but extremely fast. The point of all this is to think about our products and our materials in a new way, to have smarter and smarter products that adapt to our bodies, adapt to our environments, but without all the robotic and electronic devices, all the batteries and mechanisms that we need. We can make simple, humble materials that can be highly active and dynamic in our environment.